solving a quadratic equation in quadratic form, all it means is it has something with a square term and a linear term. So sometimes it's easier to substitute so I can see it a little bit better. So if I say that I want to let m equal sine theta, that means that m squared is sine squared theta, and I can rewrite this as 2m squared minus m minus 1 equals 0. Now, if you can do it with the signs, that's fine. I'm showing you a way to chunk it. And if I factor it now, I have negative 1 times positive 1 is negative 1. Negative 2m plus m is negative m, and I have 2m squared. So that tells me that m is negative 1/2 and m is 1. So now I need to know is when is sine theta negative 1/2? Well, it's negative 1/2 at pi over 6 and 11 pi over 6. Oh, sorry, negative 1/2 is not pi over 6. It's actually 7 pi over 6, 11 pi over 6, because it's in the third and fourth quadrant. And when is it 1? At pi over 2. So if I'm only looking from 0 to 2 pi, that's where I'm looking. Let's look at this one here. So I'm going to let m equal cosine theta, and then m squared is cosine squared theta, and here I have 2m squared plus m is 0, or I could take out an m, so I have m times 2m plus 1 is 0. 2m squared plus m, so that works. So I have when m is 0 and m is negative 1/2. So when is cosine theta equal to 0? Well, cosine theta is equal to 0 at pi over 2 and 3 pi over 2. And when is cosine theta equal to negative 1/2? Well, that's in the second and third quadrants, and it's negative 1/2 at 2 pi over 3 and 4 pi over 3.